Okay, so today we have another Codeforces round. It's some sort of anniversary because it's round number 700. So I'll just take a moment to appreciate the path that Codeforces covered in 11 years almost. Been a very long way to 700 contests, but so many amazing things happened in the entire world because of Codeforces. So yeah, just 1 minute of silence and appreciation. Think about your CP journey and the role that Codeforces played in it, because it's definitely the important thing, the important part of it. Okay, no, I mean, like 1 minute of silence would be weird, so I wonder that. But yeah, well, D1 gathers almost 2K participants. I can't remember the last time I've seen something like this. Around here, right? Here. Oh, okay, a bit lower. Well, okay. I mean, oh, should I? Wait, problem A is interactive? Whatever. Omar likes to race a lot and he wants to play a game with you. Omar has hidden from you a permutation of integers. You ask to find any index k, which is a local minimum. Local minimum, okay. Okay, so we need some sort of logarithmic complexity algorithm, right? And I'm afraid we can't do it here. I will just... numbers are a permutation, right? So there is always a local minimum. Okay. Yeah, I think I know the algorithm already. It will be some sort of binary search. I should output something like that, right? Is it like this? Yeah, maybe. I think so. I think Kernel automatically flashes birds. No, actually, What is the best way to structure our code? I don't know, man. It's hard. Just deal with it ourselves. Oh, actually, yes. Well, they call it case, so we'll do it as well. Do we have to read something and then terminate? No. Okay. Another n plus 1, n. Okay. Okay. Well, that's okay. Like, idea is, do we want some sort of binary search? So by now we have all values in array A. That should be good, right? Oh, actually, I should sign. Yeah, of course it's not adaptive. Otherwise, we can't solve the problem, obviously, because it's equivalent. So, yeah. By the way, is it? Yeah, okay. So I don't need that ugly interface anymore. Come on. Okay. So if we, that's it's annoying that I have to check the boundaries. But obviously, like we have 20, it must something around this lines, on this line. Oh, here we, yeah, if there is no previous index or this condition holds and by the way, we can return exit 0. No. This happens and this happens. No. That's for L. Let's think about it. Like if it's smaller than boss, then we are fine. If this index is valid and this happens, then we can go to this branch. Actually, inclusive, right? Else, like if this has not happened, then we basically have to go this way, right? I'm just not sure what happens here. Something is wrong with the brackets. This here, this here, this here. This is inclusive, so actually I have no input. It asks us for next one, let's give it 1. No, actually, index its second element is 2, right? Third element is 1, first. Okay. I mean, that's not very accurate. I think that's accurate. No way. We want to do this one. I think we're good with like flash all the time. The output handle. It was spent 10 minutes. Okay, more or less reasonable solution, it means. Okay, yeah. With problem set. Oh, now, wait. Oh, yeah, I was, okay. Penton's array 1, maximal possible answer, okay. But they're different, okay. Homer likes arrays a lot. Today he's painting an array with 2 kinds of colors, white and black. 2 colors, not kinds. A painting assignment form is described as an array in the color. Okay, 0 for white, 1 for black. Then assignment the array is split into 2 arrays, subsequence of all white and all black. Okay. Number of elements if we merge all adjacent elements with the same value. Okay. As large as possible. Oh. This answer asks minimal. Okay, so there are different problems. I forgot. Huh? Oh, because okay. I forgot for that reason. Okay. So we want as many different segments as possible. when we color in two colors. The first one, one, two, 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 three, three, three does not matter. Like, or if you want maximum as possible. If you want max as possible, then we put one. Yeah, we split each group. We split each group. In second, and can we color like everything white? I think we can. Yeah, we can. We can choose. So how to make maximum number of segments? Actually, they are of the same value, so it's unclear which one is easier and which one is harder read. Oh, like a sequence A1 and 2. Actually, whenever we consider, let me add an integer in between AI, right? So we know it is going to, like, what if it is some sort of DP, right? You know that this integer will end up being the last element of one of the colors in this moment. We went all the way up here and we want to think of what is this integer. Like it can be either here or here. We have two colors, right? Suppose it's in black. If we are optimizing like for array is not sorted, nothing, right? Okay. The array is not sorted. Like in previous solution, like every possible partition and was ending in AI -1, right? So without loss of generality, we may assume that it's in white. What happens when we see a next? So, I want to maximize number of different segments. So right, there is some AJ which is optimal, but how do we know that AJ is optimal? Maybe there are different solutions with different AJs which have optimal seg count. We clearly can't allow them all into our bag, right? Just curious, what is here? Okay, maybe later. And we can't solve it with dp because state of dp depends on what is the last element of black sequence. So here, like all elements are here, but here ej is here. Maybe there are multiple pairs, multiple values of j for which there is an optimal solution with aj here. With different ajs. Because of different ajs, maybe we want, if we want to maximize, we want to append to a different number, right? So maybe like in some solution here, aj is different, and in some other solution, aj is the same as ai minus 1, and the same as ai. So we want different values here. So maybe that's a solution. What if I maintain two states of dps, like longest if these are equal and longest if these are different? Do we really not care about how different they are? If they're different, then we can append to at least one of these. Maybe it matters which we append. Like if we have white and black here, the element 2 comes in, right? Maybe here we have 2, and here we have 3. We say, well, okay, we'll append here. Yeah, it does not matter what it is, because once we append here, it becomes overwritten. And why it is beneficial? Well, suppose we have like, no matter what next number we have here, we'll be able to append it here. With the sole exception of 2 being here, but then it does not change anything if we append here or not here. So I think okay, so 0 is last one. One means 0. What would be an initializer? So we understand. If two first numbers are the same, then oh. And by the way, numbers are not huge, but I don't think it matters. We may assume that by the way, no, actually, how do we know if there's look. Okay, here we have 2, here we have a solution and 3. And 3 comes in, right? We should put it here. Then another 3 comes in and we don't know where to put it, but maybe we had 1 somewhere here. This 3 we could have put it here. So then we can put both of these 3 here. This 3 is better here than it's here. So it won't work. Oh. No. So up to M, maybe it's important. Actually, as long as numbers are not like consecutive duplicates, we can put them just straight into our sim. Right, and if we have but it sounds like greedy and it should not work in D1B. If I have 3 and 3 here, actually, I have 3 and 3 here, then we probably must want to add them here, right? Then what's here? What if we just add everything else and does not fit here? How can we really be more optimal? Whenever we just scan from left to right, whenever number is different from previous, we put it into first array, and then we put everything into second array. How we can be more optimal? Maybe we can if we have two. Yes, okay. Have 2 numbers. In between, I would work on the 2. Suppose we have something like that. Then, like this partition, when we take every element unique and different from the previous, it's not optimal because this ends up being like this. And what we really want is something like this. In fact, let's add it straight away to our test pieces. What happens if we put it like this? Here goes this one, here goes this one. This one has nowhere to go. So we can put here, this we can put here. If number is different from bus neighbors, if number is different from bus neighbors, maybe we want to put it here. If, for example, 1 is different from both previous numbers. And we'll continue going like this. That's how there's nothing we can do. Yeah, look, if we have like 3 numbers in a row. We have A, 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 and there is no way we are getting 3 different segments out of them, so it's we won't succeed. Right? Won't succeed. We can immediately assume that all groups that we have in this subtask have groups like in either 2 or 1. Then we can separate 2 neighbor groups if there are at least 2 numbers between them. Then we can separate. If there's only 1 number, then we can't separate. And I believe one approach to doing this is the following one. I actually want index. I want index. Does it matter how you start or it doesn't? Does it matter how you start? Okay. I'll do something like this. So now V is not empty. Can't always push back here. It's different from boss. Okay, it's different from boss. From boss. Different from boss previous now. Here. Let's separate it into this different. Here we want to push back here. Wait, what if it's equal to be back? Can't we just say like if empty? What if we just say like this? Right? So it looks like regardless of what happens here, we're going to push it back. Is this the right thing? I'm having troubles understanding indices, sorry. Oh, what I actually like. Okay, maybe we can do it like this. Kind of balance. Yeah, I got. Well, no, okay, let's keep writing in case we will need to do this later. But this way, this time, we want to push back in different time. I'm not very confident in this solution. I did not prove it, right? So how can I be confident? 7, excuse me. Makes sense. Here we should see 6 as well. Now let's make something random. By the way, I wanted to rename to 3. How many numbers are there? I guess it does not. Here, right? 14 it says. Let's see. There's obviously this part that it can't get around. There's also this part, and you have one with the same number. No. I think here we can easily make everything that we want. I don't have nowhere to put. Here actual answer is 15. But we make an error here. But we decided to test ourselves, not in the system tests. So, okay, 1 goes here, 2 goes here, and 3 goes here. Wait, it's unclear why we failed. If we push back to the same that we don't want to change, Oh man. I feel like I'm missing some idea because people are solving it and I'm not. Miss Boss these twos because two went to the previous same part. It's not a good thing. It's some more. So yeah, we consistently skip these twos, but like actually, oh here this one is failed, right? So, wait, is this the correct answer actually? I saw that you can somehow. Wait. One this to be card and this to be card, then you can. No, but then this has to be here. But okay, so now it's correct. Actually, what happens here, like if previous is equal to the next, then we want to shade off, to shield previous. Oof. Must be some rigorous proof of how it should work. We not do rigorous here. We already said that if we have three equal numbers in a row, then something will fail. Can't get three segments out of them. We also said that if we have two, one number between them, and it will also fail. Maybe if we have more than, okay, maybe. Listen. Maybe we don't want to be smart, okay? Suppose we don't want to be smart. No, that was a mistake. Let's say we always keep first numbers. Let's go starting from the third one. If it is not equal to at least one of the previous two, we should back. Because if it's equal, like we already discussed, that there's no way we can separate three numbers into two sequences. Now the second problem that arises is like if we have situation like x, x, y, x, x, and there's no way this y can separate two groups of x's from each other, right? If these go into different groups and these go into different groups, there's no way you can place one value between them. I think the condition for this is like 4 out of 5 is the same. And after this, we did this, there are now groups of 3. The only way you can get 4 out of 5 is exactly like this. And for each such thing, you have to pay -1. And max starts at this size. And we consider tuples of 5. I is the central element. We have two two following elements. So if bi minus 2 equals minus 1, I plus 1 equals I think that if these conditions hold, then we have to decrement them, right? I feel like if we have at least 2, then we can separate clearly. There's no problems whatsoever. Even if these 2 are equal numbers, we can still separate. 6 is correct number, then we should say 7. And we should say 6, I believe, because test case is something like 1, 1, 2, 3, 4. 1, 1, 2, 3, 1, 1. Here we should see, no, actually, there is no such one. Here we should see 15. What? Did something wrong? What? Oh, AI. Okay. Come on. Right, this is correct. Now we should see 6, I think. Now we should see 7. Now we should see 6 again. Okay, I think now we're good. I think you can rigorously prove that if this does not hold, then you can separate these two guys. Do I have to refresh? Oh, is the key long? Okay. No, not wrong answer on pretest 6. So one of the two happens. We either overcount or undercount. Can we overcount? Yes, if you not always can separate numbers. Can we undercount? No. both of these conditions are necessary for -1. Maybe what if we have multiple such groups? Will each of them cause the collision? No, like each of them causes a collision. Now look, if two numbers are separated by at least two numbers, no matter which, different or the same. Have at least two numbers between. Always can place them in different places. Yeah, you're good to go. You're good to go. And if we have multiple such, then each one is penalized. There will be at least one collision. I don't understand. Hmm. We have four subgroups, each one causes a collision. Wait. Yeah, each one causes a collision like eventually, even if they change together. Look, three equal numbers in a row clearly can't distribute. So we can ignore one straight away, which we do. Like this for loop, simple says like we have three duplicates in a row, ignore. Goes like this. We have three duplicates in a row, ignore. So AI won't be pushed back into B only if it's both equal to previous and to pre-previous. So we have three duplicates in a row, then we don't push back. Then we have only two duplicates. So like we still have a problem if we have A, B, A, and there's no way B can separate our groups of two A's from each other. So we subtract one for this. Next time we see if we see two different numbers. Suppose we say a, b, c, a. Have any other problems that may arise? If we have a, b, c, a. No, if we have two numbers equal in rows, then we can simply place them into two different places. Then no matter what comes next, they will be separated, right? Unless we have like a, b, a. I don't understand, like something like this should work. Most our conditions are like 100% true. The only thing that may be wrong is it's like there's something else that makes our life hard. But I don't see what can make our life hard. Whenever we see two numbers, which is the same group of two, right? After we reduce the groups of three and more to groups of two, our only concern is like we have groups of one and groups of two. Groups of two, they eventually reset the size, reset the state, send the same number, unless it will come up two times in next three quarters. It's only possible in this condition. I don't understand. If we have one number, have two numbers between groups, BB, AC, BB, and we separate BAB, so BB. What is wrong? These conditions should be correct. I'm more or less writing the proof at the moment. We clearly have to get rid of groups of three and more, right? Reduce them to groups of two. Now these groups of two I don't understand. I really don't. What? What? Oh my god. Now I have to fix it. Oh, what the hell? How is that fair? Okay, what's wrong? If n is small, then we can just print the answer. Indices are one based, right? We can't. We can say that the answer is 0. It won't change hands. Then, I literally forgot to print exclamation mark. How can I be so I literally forgot to print exclamation mark. Oh, I'm very angry. Okay. We still can't solve B, right? Have three equal numbers in a row, which is exactly what we test against here. And we push back it to B. Here we test that out of four numbers, this is equal to this. So 2 before, next, and 2 next are all the same number. I have to decrement answer by 1 because there's no way we're separating them. If there are at least 2 numbers in between, we can just place them in different sinks and then we separate everything and we are good, right? If we have at least 2 numbers, then we can supposedly basically placed all groups of 2 to different columns, right? Then we have to place remaining values. Our residual equal values, we place them into different columns. See groups of 1s and we ignore. We will place them later. So each group of two we place into different columns, and we see what remains. We have at least two numbers here, and we just place groups of one in an alternative fashion. Alternating, okay. I'm just curious, like, wait. See, groups of one, we don't always can place them in alternating fashion. But if it's CDC, have to place C's in different, so C goes into different column. No, like if we have a group of unique characters, then like no matter how many unique characters do we have, if characters are unique, then we can simply place all but first. First into first, all but first into second. But it's not that easy. Yeah, actually, what happens if we have not like that, but what happens if we have 1, 1, 2, 1, 2, 1, 1? What will our solution tell us? It tells 7. But how do we separate into 7 groups? Here we have to place here, and now it does not matter. Oh, okay. So we have that sync when we have like bigger windows. How to deal with them. This problem like persists no matter how many values you add, so you can have. Then you just have to keep pushing here. But, well, you don't actually have to keep pushing. You can push here, but then it's like the same problem. No matter where you push here, you're done. If any of these numbers was 3, then we could split. We need at least 2 different numbers between consecutive groups of 2. Okay. Okay, so we have groups of 1 and groups of 2. Okay. Let's say I have, yeah, okay, so when value if AI equals equals 2, right? And then we can process these groups. How do we process? will be our answer, okay? N equal to 1, we just between sort well plus count. Unique groups always, it's always possible to remain unique. Else, so if equals wall, if it's not equal, we can simply increment it. We'll have no problems. Plus equals 2 was double y equals 1. Oh. Plus double wall equals wall. Here we have to put in between. Between two ways. Find, I guess. Okay, if it's equal to 1, there's no way we can separate them with having one value because we have to separate these unique values from themselves. Actually, this part happens no matter what. Answer should be who is undefined. What is here? Oh, because I have structured whatever. Let's ignore this minor inconvenience. The answer should be 6. Come on, okay. The heck is wrong with you? What? Oh, because it's in between count value. Is this how an ordered set works? I don't understand. Something breaks, but how can something break? Yeah, I can erase key. Come on. I might be able to do something like that. I don't understand. Oh, it breaks all the time now. Perfect. Oh man, of course. 7, as long as I remember. 6, as long as I remember. 15. And this time, because I made it 11, right? Let's try to submit these changes in place. Please say. When I don't understand. If I just must do, then we clearly can do it. There's already such a pair, and count is equal to 2, no matter whether there are 3, 4 elements, 8 elements, whatever. What happens next is we have that, like, if we have singular value, we can always place it somewhere in increment count. We have double value, right? If we have 2 double values in order, if we have, like, we can always erase, it's okay. If there was no such key, then there was no such key. Not a problem for us. If we have at least 2 different values in between, then we always can place them into different places. We have at least 2 values that are different from our key. Then we can always place them. Yeah, it does not match. Maybe something longer. No, like as soon as See, if a different pair comes in, if two consecutive pairs have different values, and we can just place them like that and then place everything in between here. Because these values are all unique, they won't match either of the sides. If, however, we have 2 and 2 with the same value on both endpoints, we would like to place them on like this and this. But what do we place in between? I say if we have at least 2 different values, which are also different from both of these numbers, and we can place them, just place them differently. First number goes here, second number goes here. Now, all these are different. So we can play them like this. If this, wait, what if we have something like this? Yeah, but we can't, right? Because we try to place them like that. We say like, okay, but then we have to place 2 here, and no matter whether we place 3 here or not, we are done. Yeah, done. We can't place these 2 differently. So either of this works. Okay, fair. What else can we do about it? Like, how this is actually characterized? Wait, is it with every alternating pattern? So if this value is always 2, and we can't break it. If this value is always 2, then we can't break it. We may have like arbitrary number of different values in between. If we have like 2 and 5, we can't break this chain. And then we end up with a problem either way. So how do now we have to find such patterns? Have to find such patterns somehow. What is an adequate way to do it? Value equals to 2, then we can just erase previous value. Oh, we need 2 equal values in a row, neither of which is our last value. Single. What would an in between look like? A single value equals, let me also say like bool good, it's original false. And then whenever we encounter it, it's reset to false. If a single value not equals to That's hard. That's hard. And plus double value not equals to value. Think something like this. So if since last double value we encountered 1 and 2, well, technically we also last single value not equals -1. Or between. Good between actually want to count as 2. L is good between. Can we do it like this? We should see 6 here. What? Well, fair. I already forgot what test case it was. Okay, 10 is the valid answer. Here we want to see a 15, I believe. 6, if I remember correctly. 7. Again. Oh man. I mean, we fixed, like, we found 2 test cases for ourselves and fixed them. I just make it on hope. Okay. That's terrible for you to understand. Like, we almost solved, yeah, everybody already solved B2 because it was not hard. Yeah, let's keep solving because that's the only way we can end up with something adequate. Now we want minimal number of such segments. We have like 1, 2, 3, 1, 2, 2. Yeah, how about that? Like, we'll rename it to B1. And we're no longer in these files. Oh, I actually think this different. So the idea is to share test cases between problems. How much time do we have now? Just okay, we have enough, or more than enough to solve this problem. Minimum number of such things. We want to merge same number together. The problem is when we see 3 different numbers in a row, where do we put sort? If we see only 2, then it's like no-brainer. Well, actually, in this problem, like each block of consecutive numbers will be merged together. So we can more or less This problem, every block of 2 or more consecutive numbers is pushed together because it does not make sense to separate it. Even if it merges another group, it will like increase by 1. Yeah, it does not. It does not. So now we have all unique numbers and we want to square them together. Like in second example, we want to alternate. Maybe we can just maintain an ordered set. Set of integers. Also, they're not really between the, okay, between, also. No, I don't understand. I'm trying to cut something and I still don't understand it. It's not good. Should think more about the problem. We can merge one. Like basically for every pair we can merge it, but it comes at the cost of ignoring all numbers between the merged pair, except for potentially the last one. So the question is really like how many pairs can we merge? Right. Like if they are not alternating, they're not like x, y, x, y, x, y, then we can't merge. We can't really merge. Okay. No, actually, then we can merge if they are alternating. So x, y, x, y, x, arbitrary number of times, it comes down to 2, right? Stinks. They're not alternating, like x, y, x, z, x, y, x. Then we can merge all x's, right? But hotel this is optimal. Actually, what? No, but if we add it here, then we like, don't know where to place the next one. Complicated. I thought that there is straightforward DPs that solve, but there isn't. Maybe there is and I'm stupid. But we don't want to believe in it, so I will keep trying. Yeah, it's okay. It's okay. I just need to think a little bit more. But when I output one without exclamation sign, yeah, all numbers are consecutive numbers are different once we collapse them. So I want to find the maximum number of pairs to merge. If pairs do not overlap, then we can always merge them. If pairs do overlap, if we want to merge two pairs and they overlap, there's value in between the middle two, then there's no way we will merge them. Right. Look at these values. Well, I can always put them here. If we want to merge current value, it comes at the expense of its previous element covers the opposite part. Actually, all previous elements go to the opposite part. All elements in between have to go to the opposite part. Oh, what is that? Uh, hmm. All elements in between have to go to the opposite side. Well, let's here have to go here for us to be able to merge two such things. Is it always beneficial to merge? That's my question. Whenever is the first time we encounter a possible merge? Why not actually? Like, what do we lose? Worst case scenario, we lose one. Yeah, what if we just merge every time we can? What is a good way to model it? We'll need an ordered set. It's tradition of calling it between. Count, which will be our answer. Something here. If between there's already AI. Not exactly. It's complicated. Like last value. Last value will be in a different place, right? But it should be in between. Okay, let's put it this way. If it doesn't happen, then last value automatically gets updated. So, okay. Last value should remain in between. But also AI should get in between. But who should be the last value? That's the question. Oh, that's unclear. We want last value that's not equal to the. Oh, you want to say it does not matter because next time we won't see AI, but we may see that thing, right? We always want to insert AI because AI always can form a pair, right? But we also want to insert last val. But here we can safely say that last val. No, last val always equals to AI. It's just the nature of this variable. Yeah, because we don't want actually minus -1 to be here. I don't care, like it can't form a pair. Right, it can't form a pair. I actually forgot all my test cases. So, case B1, minimum number of segments is 3, there is nothing to discuss. Here, minimum number of segments is 7, also nothing to discuss. Here, minimum number of segments is 3, I believe. Okay. But what is the minimum number of segments here? I actually don't know what is the minimum. Like these are configurations with maximum number of segments. It says add. That's going deleting everything that's extra. Can we do better than 8? Can do here. So here we'll have 2 and 1. Right? No, here we can do 7. Right? But why in both? Like this part, we did the same. We reduced. And we say like, okay, 1, 2, 4, 3, we accumulate sets. Then we say like, oh, we find a pair in number 2. So we clear our set. We insert also 3 here. And 2 will be in the set. So 2 will be in the set. And we say like, oh, okay, we have 2 and 3 in the set. We keep going, keep going. Here we face 2 again. We say like, wait, oh, we have 2 in our set. Let's go here. Previous value is 1 at the moment. So we'll retain to the set. We keep going 3 and we see 2 and we say like, oh, okay, 2 is here, 3 is here, 1 is here. Maybe I don't do something right. I just described my algorithm and got different results with it. Okay, let's make sure that other tests are valid. Like here, answer is obviously 2. The answer here. And answer here should be 4. And it is like all 2's can go in the same part. What is the answer? Here the answer should be 4. Right, we can't put both 3's and V8. V8. Oh, this is this, right? The answer should be 2. Okay. What is wrong with V4? Oh, I need a break. I'm sorry. I drink too much tea. Okay. We still have enough time, so we should be able to figure it out. A count of segments increases only when we encounter this. How about we simply we iterate over A, and that's so silly. Okay. How did previous tests passed, not pretests? Okay, so here answer is 7, which is correct. Now we have to do the same thing again. So here answer should be 3. Okay. Here answer should be 7. Okay. Here answer is 3. Okay. Here answer is 2. Here answer is 4, because we have that many unique numbers. That's a natural lower bound. Here answer is 4, I believe, because we can't place both 1's and 2's in the same part. Here answer is 2. Here answer should be 7, just to check here. Okay, I'm not 100% sure, but in this contest we were never 100% sure, so does it really matter? Okay, we are still terrible. Don't misjudge the standings. Right, 500 people solved all these questions. That is really silly and costed us a lot of time. endpoints. I really should not delete all these test cases. Some time ago, Homer lived in a beautiful city. There are n blocks numbered from 1 to n and m directed roads between them. Each road had positive lengths, and each road went from the block with a smaller index to the block with the larger index. Okay, so we are originally given a topological order of the graph. Cool. Every two different blocks, the westmost one out of them. Okay. Homer discovered that some two-number city is L are continuous. All paths from block 1 to block n are of lengths between L and R inclusive, and there's exactly one path from. That basically means that blocks are like separate. There is exactly one path from block 1 to block n whose length is d. Like if there's no restriction on 32 blocks, then there obviously is such thing, right? We just create separate paths. Just create paths of length L, path of length L plus 1, path of length R. So if R plus L times R minus L plus 1 over 2 is less than or equal to n, perfect, we can solve this test case. Otherwise we can't. No, otherwise we don't know. Otherwise we don't know. Here apparently. Oh, of lengths. So block. Oh. Oh. So we can have different lengths. Of the rods. This is not accurate then we just. I mean, like, if difference between L and R is small, then we. How many vertices do we need for? Oh, there's at most one. Wow. There's at most one road between them. Yeah, because otherwise it's possible, like, no matter what is the number of vertices. So here we want to check against 30 actually, because I can print it straight away, or do I have to print? Yes, okay. That's n. If r is equal to 4 and l 4 and 6, I want to have, is it true that l, well, if l is equal to 1, okay, I can have one direct pass from, okay. So complicated. Yeah, I want to take a break from recording just so that I can focus a bit more. Okay, so I think I actually know what's going on in this problem, but there is no way we're going to do it in 10 minutes. So like the trick is the following. The trick is the following. So like obviously we want to make more paths of less vertices that we have. So suppose we have following construction. Say here goes x. In these two rows, no matter what they are, they just sum up to x plus 2. Here we have road y, and here we have y plus 1. And potentially here we have like two rows of overall length z plus 4z. Here we have a rod of length z. And then you can basically see that like no matter what we select, we get x plus y plus z. And then we can select an arbitrary combination of bits. And for such construction to work, as you can see, we need like for k bits, we want 2k vertices. I think 2k plus 1. And you may say like, but that's not enough. That's not enough. Because like L and R are both up to 10 to the 6. So we have up to 20 bits, potentially on 21. But we only have 32 bits. But we would like to have like 43 bits at least. And also it is not perfectly clear. If L is very small, we always get X plus Y plus Z. We can't say like, okay, let X, Y, and Z be equal to 0. Because lengths are positive, so it's at least 2k. That's another problem. With this approach is that like length of our shortest path is bounded. And that's like the first problem is there are not enough bits. First problem is that there are not enough bits. The second problem is that L is bounded in such construction. There is a third problem, and the third problem is what if r minus 1 is not power of 2? Like such construct, well, not power of 2 minus 1, right? So such construction basically gives you two choices on every such thing. You may say like, well, okay, I will add like the same construction just all the way here. And it may actually work, but then you again need numbers here, right? And for these numbers, you need more bits. No, the number of bits does not change, it's like 21, but you need more vertices. So like, this chain emulates that you have, suppose that your number L minus R decomposes as sum of several powers of 2, or R minus, yeah, 1 plus R minus L decomposes as sum of several powers of 2. Like one possible construction that has more bits and more vertices than it should have is the following. For you decompose your interval in several such intervals for the length of power of 2, and then you can solve each interval in such lengths. But like this solution needs n. So for this construction to work, we need n to be n is at least, let me write it like that, log squared of R minus L. And we are nowhere near that number, so that's like something 441, and we have only 32 bits, 32 vertices. There is really, I believe that the solution asks you like, so if you can't build with this construction, then you can't build because it's like the most efficient. If you try groups of 3, then you can get like higher branching factor. You can have more paths between pair of vertices, but you get like 3 paths at the expense of 4 vertices. So you get like 3 paths per 4 vertices on our, well, okay, let's say ignore the finish, right? Then you get 3 paths for 3 vertices. In our construction, you get 2 per 2. If you want to maximize towards the product, then you basically want 2, right? Because like you will multiply these numbers. So you're interested in like, what is log of 3 over 3? What is log of 2 over 2? And this wins. So you want to build with such construction. But then, yeah, I don't know how to prove it strictly. Like it's like a hand-wavy idea why we want something like that. But I have no strict proof. And even if it's correct, we obviously can't implement it in like 3 minutes. So yeah, unfortunately, I will end the video here. And yeah. Well, obviously we messed up with A. I still can't believe that I just forgot to print exclamation mark. Then it was long. Yeah, I should have tested B better myself. But then B2, we already had the tests and it went more or less smoothly. So I think we will end up with like something minus 25. And if we did not mess up with A and we did not mess up with B1, then possibly we could have ended up with like plus 25. But it's like theoretical now. And we don't really value theoretical estimations. So yeah, it was not a good day, but clearly I need to solve more construction problems because B1 and B2 are more somewhat of a construction problem. I don't really have to solve more interactive problems, but I may will. I mean, oh, actually, like I think there are no good tutorials on YouTube on interactive algorithms, so it may very well be the topic of the next video. I mean, of the next educational video. There's obviously no such gym, but maybe I will just gather a bunch of interactive problems, create a mesh app, and we'll train them. So that's it for today. Thanks for watching. Hope you found these solutions more or less understandable. I mean, like first is binary search, and then in B1 and B2, we more or less, like in B2, it does not matter which pair we select when two pairs overlap. If we can't select both, then no, it does not matter which we select because it will cancel one pair either way. In B1, you just want it. Yeah, after these observations, you can merge blocks together. First problem, you can merge blocks into lengths of at most 2, in the second most 1. After this observation, you just need to carefully process the blocks. So that's it. So yeah, thanks for watching. And I guess till the next time. Bye-bye.